So what program were you using?
What was I using?
No, Seth.
What's going on?
That's in the quantitative inference procedure?
Yeah.
Okay, yeah. I had that one pulled up. It looked like he was doing something different than that.
Yeah, well, there's different tabs on the bottom if you look.
Yeah.
And well, sometimes it's SPSS.
That's what
but,
SPSS.
Yeah, but you don't.
We don't do that.
I think Excel's, you can, but I think Excel's better. Alrighty. Well, if you guys, was there any other questions, or I think?
Nope.
We're good.
I think I'm good. You can go ahead and start on the test. I mean, this wasn't too difficult. It's just pretty much plugging the numbers in and kind of interpreting the data. So it wasn't too difficult. So I'll go ahead and start the quiz if you guys are ready.
Okay.
Oh, sorry. Oops, I almost started quiz 13. Quiz 12 is first, right?
Yep.
Okay. Oh, yeah. Chapter 12. There we go. All right.
There we go.
Okay. First two, we answered there. So, yep. Okay.
Oh my goodness.
Okay. Okay, I'm going to open up both. Okay, yeah, so question number 3. Okay. Suppose we have a set of paired data. D. Let's let D equal X after let D equal X after between X, before, whatever, okay. X1 through X2. The null hypothesis is the mean difference is 0. The alternative hypothesis is the mean difference is not 0. In the population, standard deviation is not known. Jordan collects a sample size of 9 and computes D equals 2.2. And standard deviation is 3.3. What is the test statistic? Okay. So let's find the test statistic formula. Okay. So do you guys have the test statistic formula?
It was pretty similar to the last one. It was like T equals me minus theta.
So it's T equals D bar minus 0 over SD over square root of n. So so it's 2.2 minus 0 over 3.3 divided by the square root of 9, which is 3.
So it's, you said.
What was that equation? What was that equation again?
Oh, it is, so it's t equals d bar. So it's little d bar, which is the
Right.
mean difference,
Mean of
minus the mu difference, which is always 0. So it's d bar minus 0 over SD, which is standard deviation of the difference, divided by the what is it? The sample size squared. So n square root of n. Yeah. I got answer 2. What do you guys get?
Because I looked at that equation, and that's actually a question that I figured out that I had. I was like, where are they getting 0 from? Where are they?
Yeah, well, it seems like, make sure I'm on the right notes here. I've been having to take quite a bit of notes. Yeah, so it seems like on the paired samples, unless otherwise specified, I think a mu is always going to be 0. That's my assumption. So, did you guys get 2?
Yeah, I got 2.
Moving on to number 4. The probability of obtaining a test statistic greater than Jordan's test statistic. Well, the probability of obtaining a test statistic greater than Jordan's test statistic. Okay. Hold on, I'm confused here.
Wouldn't that be the p-value? Doesn't p stand for probability?
Hold on, let me think about this one. This is a tricky question. So we're going to be using the applet thing, the t probability applet. I'm just trying to figure out which value. So
we just got t, which t equals 2.
Is it for the same question?
Yes. I think.
I can't
yes,
tell.
it's talking about Jordan collects his sample size. Yes.
The next 2 questions.
Use the following information for the next 2 questions. So that's for 3 and 4.
Yeah, I see it. Yeah, I see that now. So I'm trying to figure this out. So the probability of obtaining a test.
So do we enter in 2 for the
2? Question 3
like
answer
these?
is number 2. Yeah.
That's greater than
Probability of
0.043.
greater than Jordan's test.
What was the sample size?
9. So that's
So are we just entering in 2 for where the z-score would be? So it's the t-score. So then would it be?
Yeah.
Sorry, 0.991.
Yeah.
I guess because if you're rounding up.
I have no idea on this one. I'm gonna be honest. This one wasn't really on the homework or.
Do we want to just put 0.92 and see how it goes?
So hold on. The probability of obtaining a test statistic greater than Jordan's. Okay, so let me mess around with this. Okay, so we know that degree of freedom is going to be 8, right?
yes, because the sample size is 9.
So, and we know t is 2. And we're just going to go greater than. So, what is it? What are they asking? And then the area for greater than, I'm getting 0.0403.
Yeah, which is the statistic that they were asking for, but I don't know if that's.
Is this probably determine p-value? I thought that was the p-value.
Do we plug that into something?
I'm trying to figure that out. Yeah, I thought I would thought at this point then 0.04. So the probability of obtaining a test certificate greater than.
You just want to go skip it and then come back to it?
Yeah, I guess so. Okay. All right, use the data file, chapter 12 data. Okay, use the next 6 questions. So I'm going to pull that up. Bear with me a second, my computer's thinking about it. What is a test statistic? Be sure that, okay, so put group 1 in the first column and then group 2 in the second column. Okay.
So I got 0.407.
All right, I'm still doing it. Yeah, me too.
Yeah, 0.407.
Okay, 0.407.
P-value is 0.689.
Yep.
Let's make sure. So we're doing not equal. Let's make sure it's not equal to the type of test, and mine is. So do you say 0.689?
Yes.
Okay. That's what I got. What is the correct decision based on evidence? So now we're going to reject, or we're going to reject the null hypothesis.
Because T is smaller than P?
Or because P is larger than significance. To reject, fail to reject.
Fail to reject?
Yeah, because P is larger. If P was smaller, we reject the null. P is low, reject the null.
So
But
P
when
is greater than
large-
T.
No, it's not T, it's alpha.
Oh,
The
that
fishy
was a big
thing.
question. Oh,
Yeah.
so it is larger. Okay.
Yeah, so we fail to
If
reject.
it's larger, it's fail to reject. If it's smaller, then it's reject.
Yeah.
Yep. P is low, reject the null. Okay. 8. Suppose your alternative hypothesis is HA is greater than 0. What is the correct decision based on evidence? So now we just go to, it's going to be the same decision. But now you just go back to your spreadsheet and click greater than instead of whatever it said. And then we have, let's see here, insufficient evidence that the mean difference.
So we have sufficient evidence that the mean of the difference is greater than 0?
We have insufficient.
Oh. That the mean of the difference is greater than 0?
Yeah.
So what would we need to know in order to be sufficient?
Well, we would say we have sufficient evidence if we were rejecting the null.
Okay, since in the previous number 7, we do fail to reject because p-value is greater than alpha.
Not necessarily, because it just so happens that if because out on the one above we're saying it was equal to 0, but now we're saying it's greater than 0. But even when it's greater than 0, it's still large. P is still larger than alpha.
Okay. Okay.
Okay. Move into number 9. Okay.
Wait, just so I'm clear, so we chose insufficient evidence that the mean of the difference is greater than 0.
Yeah.
Okay.
Looks like a new spreadsheet here. Dang it.
Yeah.
Is that a different one already? That's really quick.
Wait, hold on. I missed it.
Right?
What did we get for number 8? Sorry, I was trying to load something. What did we get for number 8?
No, that's different. There's not.
So
What question are we on?
So for number 8, we got have insufficient evidence that the mean differences is greater than 0.
Okay. So now we're loading the next spreadsheet.
We back? Hey, can you guys hear me?
Yes, now I can.
Okay, sorry. I'm not sure what's going on there. Okay. Well, I'm just pulling up this different spreadsheet.
So it says to use SPSS, but we should just use Excel, right?
Yeah.
So they need to fix that.
It's implied.
Yeah.
We put group 1 as B again? So is it the same thing?
No, group 1 is in value 1.
Yeah. Okay.
So N is greater. So I got N for number 9.
All right. Give me 1 sec.
What?
Okay.
The computer is glitching out.
Issues right now.
N is 22. Oh yeah. That should be an easy one. We should know that one up front. So yeah, N is always greater than degrees of variance. Okay. Question number 9. What is your p-value?
P-value for number 10, I got 0.001.
Yeah.
That's fine.
Then
So what you got for 10?
I got
Here,
what?
Hey, give me a second. Let me see. Hey, what'd you get? You got for 10? You got 0.001?
Yes.
Okay. And then for
Hold on,
11.
Sorry. I was still copying and pasting. I was having issues loading the thing.
Okay.
Let me see if I can get 11. I think I'm doing that right. So wait, Thomas,
Yeah.
for 11, did you get reject the null hypothesis?
Mm-hmm.
Okay. No, I think I understand that now.
Yeah, because P is lower.
Okay.
Okay. So we're on 12?
Yeah, we're on 12. And let's see here.
We decide to try another alternate hypothesis. This time you use A, you mean the difference, and you keep the same level of significance. Did the p-value increase or decrease?
Decrease.
Hold on, what are we doing? Are we doing greater than or less than?
I think it's greater than
If
because
the difference is greater than 0.
Okay, then it decreases.
so we reject the null hypothesis.
It decreases, and we would still reject the null, yeah.
So if it went above 0.01, we would fail to reject.
Yeah.
Okay, that makes sense.
Previous question. Based on your reasoning from the previous question, what conclusion do you make? We have significant evidence that there's no mean difference between the two groups. We have significant evidence that there is no mean difference between the two groups. Wait.
It's C. We have sufficient evidence that there is a mean difference between the two.
We have
Just a question.
sufficient evidence that there is a mean difference between the two groups. Okay.
Wait.
The differences that they're using is no mean and regular mean, sufficient and inefficient, and it switches between those.
Oh, okay. I was like, they're the exact same thing. Sorry.
That's just picky verbiage that we have to be using there. Okay, as we have seen, the p-value depends on the alternative hypothesis. In general, which of the hypothesis will give us the smallest p-value?
Well, wait. I thought we were still on 14. Where are we going to 15?
We're on 15.
Are we?
Yeah.
Okay.
Oh, 14 we got.
For 14?
We got C. We have sufficient evidence that there is a mean difference between the two groups.
All right. How do you know if it's a mean difference or not?
Well, because we're not saying that they're the same. We're saying that they're not equal, and then we're saying that they're greater. One's greater than.
Oh, okay. I see. That.
Does that make sense?
Sorry.
Okay. No worries.
Yeah.
So I know. So for question 15, I know it's not the first one. That's for sure. It's either greater than or not enough information. Think for a second.
It's greater than, because the mean difference is.
So
mean difference is 11.955.
Yeah, but I don't think this is just in general, not just for this specific situation. This is in general.
yeah, I don't think it's
I know
A or B.
It's not A or it's. I know. Yeah, I'm certain it's not A or B. It's either D or C. So I'm trying to think. How do we solve p-value if we don't have? We do.
Which alternative hypothesis?
We don't have enough information. That's the answer.
Yeah, that's what I was gonna say.
Yeah.
And why is that?
Because p-value is just, if it's less than, it could be larger. It just depends on what the test statistic is.
Okay. Because the one that we just did, I used the not equal to as well as the less than, and it was greater than. So
Yeah, the not equal to is typically is always the second largest. That's for sure.
yeah.
But it always depends on what the test statistic is. So
Okay.
because if we have a negative test statistic, greater than is larger. But if we have a negative test statistic, less than is larger. So okay. Let's go back to the test. Okay, where are we? We're on number 16. Okay. Determine the 95% confidence interval between groups 1. Which, does it say which spreadsheet we're using? I assume spreadsheet B.
Be the.
Yeah.
I think it'd be the T1 because it's with T value.
Yeah, but which spreadsheet are we using? I'm talking about which data. Are we using data, chapter 12
Yes.
data A or chapter 12 data B?
B, because in the question, in the information above 8, it says use the data file a blank like the B1 Excel to answer the next 8 questions.
Okay, yeah, thanks, Seth.
No problem.
All right, so 95% confidence interval.
0.80. Or sorry, 2.08.
Give me one quick sec. I'm trying to figure something out. Okay, that's what is it asking? I didn't even read the question. Okay, what is the point estimate for 95% confidence interval? Okay, the point estimate is T value. So do you guys 3.73? Sorry, 3.7. Yeah, so 3.737.
Yeah, is the T value.
Yeah. Okay.
But would you plug that in, or wouldn't you just plug in the 0.95 because it's the area, right?
Yeah, so we just put 0.95 in for the confidence interval, and then whatever our T value is the point estimate or whatever it's called, the test statistic.
Why is there?
If we change that from 0.95 to, let's say, 0.90, does that change the test statistic? It doesn't. Is that what you guys think the answer is for number 16? It's 3.737?
Yeah.
I don't think it's that.
What do you think it is?
Because the T isn't the confidence level. The confidence level, isn't that where you plug in and you find the area from like here to here?
Yeah, but it's not asking for the confidence interval. It's asking for the point estimate.
Because that's for the lower bound and upper bound.
Yeah.
That's later on.
Yeah, that asks a little bit lower.
Okay, then yeah, 3.7.
Okay, so now it's asking for the margin of error.
Isn't that just? That's just it's.
So you calculate the spread between the upper bound and the lower bound, and then you divide it by 2.
My notes are all over the place.
Did you get an answer, Seth?
I got 11.955.
Isn't the margin of error?
Oh, wait.
That's not what I got.
Deviation
No.
Over the square root.
I got 6.652.
Okay, me too.
Sorry.
Yeah, there's a formula for it, but you can solve it much quicker if you just subtract the upper bound from the lower bound, and then divide that answer by 2.
Oh.
I got the same answer.
I just added those two together, divided it by 2, and then subtracted that number from either or. It doesn't matter.
Yeah. Well, I guess that's one way to do it.
Right?
The long way.
So wait, but Seth, you got 6.652?
Correct. Yeah.
Okay. Lower bound 5.303.
Yep.
And the upper bound is
18.607. Yep.
All right. Let's see if we can't go back up to that one earlier and see if we can figure it out.
Yeah.
Okay, the probability of obtaining a test statistic greater than Jordan's test statistic is 0.0. This is probably determining p-value for Jordan's hypothesis test. I think it's the same answer. I think it's
0.0403.
Yeah, 0.0. Well, so we round to the third, so it's 0.040.
Okay.
I think that's it. That's got to be it because the probability and the p-value are the same thing. That's what it's supposed to be.
Yeah.
So,
But of p-value of hypothesis.
hold on.
Yeah, I'm thinking it's actually. Let me test something.
Oh, no.
Is it 0.9 or 0.920?
No, so here's what I'm thinking, guys. So
It's just the center?
hold on. So we know what we know right now. We know that the probability of getting a p-value greater is 0.0403, right?
Yes.
So that's just highlighting one side of the probability applet.
Yes.
But Jordan's alternative hypothesis isn't greater than or less than, it's not equal to. So I think we highlight both sides and then that's our answer. So it's 0.0403 times 2, which rounds up to be
0.081.
Yeah, is that what you guys, I think that's the answer.
Oh, so it's not equal to?
Because what Jordan, when it's asking the question, it's asking what Jordan's original, she's like, so they're saying the probability of getting higher than the test statistic is 0.0403,
Oh,
right?
okay.
So that's just one side. But Jordan's, and then it's asking what is it for Jordan's hypothesis test. And Jordan isn't asking for one side, she's asking for both sides. So I think we just do 0.081.
Okay.
What do you think, Samantha? What do you guys think, Michaela?
Sounds good.
Okay.
Yeah, it was either that or it's 0.920.
Where are you getting that?
Well, I was thinking that it wasn't the null hypothesis, but I understand where you're getting it of not equal to.
Okay.
But
so
that's what.
I'm going to go ahead and submit it and see how we do. %. Okay, what did we get wrong?
Oh, number
Probably
16.
Number 16.
Is that the one you guys missed?
Yeah. Okay. Think about it.
Point estimate?
What is the point estimate? Let me see if I have it. Seth, do you want to go back to the textbook, see if you have anything on a point estimate?
I did a search on that and nothing showed.
Huh.
So I'm just asking my best friend right now, Google, how to get point estimate.
Okay, so point estimate is a sample mean. I have that right here.
Yeah, the sample mean X is a point estimate of the population mean mu.
Okay, but we don't have mu, do we?
Maybe.
No, so what I have is from what I got from the what I have here is what I just wrote down from the video, and it says X bar equals sample mean in parentheses point estimate. So I think the answer is actually 11.955.
Wait, where are you getting 11.955?
Because that's the mean,
No, that's
the mean of the difference.
Is that using the same?
I think that's the answer, because we're not talking about one individual sample mean. We're talking about the two sample means, and we're trying to find the difference between the two. But do you have the difference mean of 11.955?
11.955, yeah.
Okay. Do you guys want to try it again? Just run through the test and then put those numbers and see if we get that answer?
Yeah, that works.
Okay. I'm just going to copy and paste everything over. Like put them side by side because we got everything right except for that one. So I'm going to write that down, 0.955. Or 11.995.
Yeah.
Okay. I think that's it. Pretty confident. So let's go ahead and take this test again. I hate doing that. I hate having to do it again. Okay. Whew. Do you guys know we have another exam next week? Isn't that crazy? It's going by so fast.
That is crazy.
Going by so fast. And thank goodness. I actually somewhat enjoy this class, but it takes up a lot of time. Okay, quiz. All right, group quiz. Okay. All right, I'm gonna go ahead and start the next group meeting quiz.
Wait, did you already submit yours?
No, I'm just starting it.
Oh. Wait, is Michaela still there?
Yep, I'm here.
Did you already finish?
Yeah.
I'm glad we got number 4 right. I was happy about that. It's always in the same order, right? Yeah.
Yeah. I had to check on some too, yeah.
Even though it always is, I'm still always so
paranoid.
Yeah, I'm so nervous about it.
Yeah.
Okay. Number 9. I'm not seeing number 9 now.
Yeah, and I've reread the questions too on just to
Yeah. I'm right with you, man. Okay. Number 10 is 0.001. Reject null hypothesis. Decrease. 13. So have you guys been watching the videos? It's hilarious. That guy, it's like he keeps saying like, "Oh, don't worry." Someone like interrupts him. He's like, "Oh, don't worry. We'll just edit it out." He like totally doesn't edit it out. It's pretty hilarious. Okay. 16. Okay, so 16. We are not doing 3.737. We are doing
11.955.
11.955. Okay, and I'm going to double check something because actually now I'm second guessing myself. So point estimate. So man, I thought I was certain it was 3.37, but okay. The only thing I got is 9.955, so let's just go with that.
So 11.955.
Yep, 11.955. 17. 6.656.
There was that video he posted.
Did he post a video?
Well, yeah, on our front page. I don't know if that's what it was. Like, I watched it. It was like a quick.
Dang, I must have missed it. All right, I'm submitting the quiz. You guys all ready? All right, I'm submitting it right now.
I'm double checking mine.
Okay, 100%. Good job, guys. Woo! Wow, we're on a roll, guys. We're doing really well. All right. Moving to chapter 13.
Okay.
Any questions on chapter 13, guys?
Nope.
Pretty much the same thing, except we're just doing a different program. You know, just interpreting the data a little bit differently, so nothing crazy.
I think that's the main thing of this class is just being able to understand and interpret the data.
Yeah. A little bit of math here and there. All right, 13. I'm going to go ahead and start the group quiz if you guys are ready.
Yep, I'm starting it too.
Okay.
$18 questions.
Oh boy.
Yep. Last
Okay,
one
last
wasn't
one was
that bad
19.
though.
Yeah, last one was 19. We got those. All right. Starting on question number 3. Okay, I'm gonna hurry up. I'm gonna open up both of these spreadsheets real quick and close up my other two. Just give me a moment here.
Okay.
Okay. So now we're going to two sample t-test. Okay. Go ahead and delete this information real quick. All
Are we
right.
starting with number 3 or?
Yeah, let's start on number 3.
Okay. What requirements must be
So-
met when conducting a hypothesis test comparing two means with independent samples? I think
Okay.
you have to have a random sample drawn from the population, and the sample size must be the same for each group.
Sample size does not need to be the same for each group.
I'm pretty positive it does.
Well, if you look at one of them, it's already not. So if you look at freshman,
So on chapter
freshman.
13,
Oh, go ahead.
on chapter 13, it says verify the requirements must be met. A sample random sample must be drawn from the mean is normally two groups. That's right. Sorry, I checked the wrong one. I read it and then I didn't fix it. That's why.
Yeah, this one didn't have too many. I think this one just had two requirements, if I remember correctly. Yeah, it was just those two.
Was that a simple random sample must be drawn from a population and mean is normally distributed for each group?
Yeah. Oh, and then there's a third that samples are independent, but that's not a choice. So
So it's the top 2.
this is the top 2, yeah.
Okay. The test statistic of a hypothesis test comparing two means with independent samples is 8. And then isn't it t-score?
Yeah. Now let's hope all the questions are like these ones.
These samples are independent if knowing which sample in group 1 determines which sample in which subject will be in group 2. Knowing which subject will be in group 1 will tells you nothing about which subject will be in group 2.
It's number 2.
Yeah. Yeah, that's another easy one. Okay. Moving on. Question number 6 already. Okay, we're zooming through this, guys. All right. Okay, I'll read it. Okay, so this one's the dentist office bills. So if you guys want to start plugging that in, it looks like.
Done.
I always hate how it it makes a difference depending on what column you put it in, but it looks like they're making it simple for us. They're telling us the answers. So it says, okay, for the next 6 questions, use the dentist office bills. This data represents a simple random sample of dental bills from a dentist office in Idaho Falls and a dentist office in Rexburg. Let mu1 be the mean of bills, and so let the mu1 be Idaho Falls and mu2 be Rexburg.
Okay.
So let's go ahead and do that right now. I'm just going to go ahead and input that in.
And that's
so
in the
Rexburg is column 1. Yeah, 2 sample. Make sure it's on that one too. Actually, Rexburg is column 2, and Idaho Falls is column 1. Correct?
Yes.
Mm-hmm.
Okay. Just make sure I did that correctly. So Idaho Falls, Rexburg is column 2. Okay. Sweet. Okay, perform the hypothesis test to determine if the mean bills of Idaho Falls is less than the mean bill of Rexburg office, which means we have a null hypothesis of mu1 equals mu2. Let the alternative hypothesis be mu1 is less than mu2. Use a level of significance of 0.1. Okay, what's the degrees of freedom? It's just going to tell us right in our little formula here because it's a little bit different.
21.
37.996.
Yeah, I got the same. 37.996.
For degrees of freedom?
Yeah. It's different because, I don't know, it's just different. It tells you on the spreadsheet, though, on my kind
Yeah,
of
I'm
spreadsheet
looking at
calculator.
21.
What's that?
I'm looking at the spreadsheet. Mine says 21.
Where does it say? It says 21 under DF.
Yes.
Yeah, I'm not sure why it says that. Let's think here.
Are you in 2 sample t-test?
Or are you in paired sample t-test?
Paired sample t-test, you would get 19.
Yeah. Are you in paired sample or 2 sample?
So hold on.
So it's
Okay,
the
so you're in
next
paired
tab
sample.
over, so it's the 2 sample.
Yep, I got it.
Okay.
Okay, I got 41.9.
Yeah, still off.
Are you using the dentist office bills or are you using
Yes.
freshman dinner? Okay.
I think I figured it out. I kept some of my old data from the last thing.
Yeah.
Okay, 37.996.
Yeah, great. Okay. Alrighty, question number 7. What is the sample standard deviation for Rexburg?
208.875.
Isn't it 206? Because isn't variable 2 Rexburg?
Oh yeah,
It's 206.
they are variable.
Okay, so did you get 206.673?
637.
Oh yeah, 637. Does that make sense, Seth? Is that what
Yeah.
you're thinking?
Yeah, I was thinking Rexburg was variable 1.
Oh, okay.
So
Gotcha.
I thought they were trying to be tricky, but I tricked myself. So
206.637. Is that what I?
206.637. Yes.
206.637. Okay, great. Question number 8.
What is the test statistic?
That's T.
Negative 0.434.
Mm-hmm.
All right. What is the p value?
Okay, so make sure you have it clicked at less than, because we're doing U1 is less than U2. And I got
0.333.
Me too.
What do you guys mean click less than? What are you talking about?
The type of test. There's confidence level. We don't have to mess with that yet. But then the next one is type of test. And the reason is because we have variable 1 is less than variable 2 is our alternative hypothesis. And so that's why we.
Sorry, I didn't see that I didn't know there was a.
Okay, we are going to fail to reject.
Yep. Because the p-value is greater than alpha.
Mm-hmm. Okay. So, let me see that.
Now the next question, it says, suppose instead that you had used the alternative hypothesis, so you want to change the less than to not equal to.
Or, yeah, to, yeah. Same answer.
So we have
So-
sufficient evidence they're different, or
No, we have. So we have. Let me double check because I think we have insufficient evidence. If we don't reject, so if we fail to reject, we have insufficient evidence that the mean difference, or we have insufficient evidence that the mean difference. So it's B. We have insufficient evidence that the two mean dentist bills between the two cities are different.
that's
Okay.
because we can tell that they're
So wait,
It's just because
I still
we
get
rejected
confused
the
on
null,
that.
or yeah, it's confusing. So we're failing to reject. So here's how I kind of look at it to make it simpler, but I do have somewhat a good understanding, but just to make it simple, if we're failing to reject, if we fail to reject,
Yep.
you know your answer is going to start with insufficient.
okay.
And what do we have here? We know, so our alternative hypothesis was that they are different, but we failed to reject the null that they are the same. So we don't have enough evidence to determine that they are different, if that makes sense.
Mhm.
Probably
Okay.
didn't, but moving along anyway. All right. Question number 6. So now we're on to freshman dinners. So if everyone wants to so let's see here. Let U1 represent the number of times a month. Let's do it. Okay, so column 1 is Colorado, and then column 2 is Utah. So let's just make sure we quit.
Column 1 is Colorado.
Yeah, that's what. If you double check my reading, because that's how I read it, but that's what I think it is.
Yep.
Is that what you're thinking, too, Michaela?
Well, I have to, let me read. I haven't read it yet. Supposed to. Yeah, so column 1 is Colorado, column 2 is Utah.
Hold on, guys. My computer is glitching out on me again. Just give me a second. Ugh, it's so annoying. I'm sorry. Just give me another second.
I just hope they didn't mess up.
Didn't mess up. What was that?
Well, I just hope they didn't purposely write that wrong. So I just hope on our end we're
It was like that on it was like that on a couple of homework assignments. So it's
yeah.
It looks normal. Okay, so let me input the data real quick. So Colorado, column 1.
So the smaller list is on column 1.
Oh, that's a good way to look at it. Oh, gosh dang it. Okay. Alrighty, just to make sure we're on the same page, did you guys get a t-score of negative 0.845?
Yep.
Yep.
Alrighty, let's go to question number 12. So what is the appropriate alternative hypothesis? So let's see here.
Not equal to.
You select a freshman. Let me see. You suspect a freshman Utah cooked dinner for themselves, and there's a different number from the freshman. Yeah, not equal to. They don't say greater than or less than, they just think it's different.
Yeah.
Okay, 13. What is the test statistic? We just said it. I already forgot it. It is negative 0.845.
Yep.
Okay. Number 14. Oops. What is the p-value? 410 or 411 if you round. Okay.
Yep.
What was alpha?
0.05, so it's failed to reject.
Failed to reject.
So determine a 95% confidence interval for mean 1 minus mean 2, an estimate of the difference between mean 1 and mean 2, and put your answer.
Yeah. So let's find the confidence interval here. So what I'm going to do, I don't care about the negatives for the confidence. Do you guys have a confidence interval just to make sure we're on the same page of negative 5.147?
Yes.
And then 2.214?
Yes. So are we just subtracting those from each other?
Yeah,
So
so my calculator can't really, my phone calculator handles negatives odd. So I'm just going to do 5.147 plus 2.214. That equals 7.361, and I divide that by 2. Confidence interval of 3.681.
Yes, that's what I got. 3.681.
So why do you divide it by 2? Sorry, I'm confused.
Okay, so the confidence interval, so that's the total spread, but what a margin of error is the mean to the higher or the lower. So we're looking at the full spread. The full spread, the mean's right in the middle. And so we just want to know the mean to the highest or the mean to the lowest.
Okay.
But we have the highest and the lowest.
3.681.
Yeah, 3.681. Yeah. Because if you take no, it's never negative.
It's never.
It's
So-
absolute value.
So yeah, so Michaela, if you take that number, so take the 3.681, and then you add it. Is there one here? Oh no, there isn't one. Never mind. But if you took that, so if on the last question, if you would, like on the last section when we're doing paired samples, if you took that number plus the mean, it would if you take the margin of error and then you add it to the mean, it would equal the higher interval.
Okay.
So
Yep.
okay.
Thank you.
Yeah, you bet. So, okay, next one's our cake. We just talked about them. Lower bound, negative
5.47. 147.
5.147, and then 2.214.
Correct. All right, are we going to submit it?
Yeah, hold on. Wait for me, guys.
Okay.
5.147. And then the upper bound is 2.214.
14.
Yeah. Okay. Alrighty, let's do
We got
it.
100%.
What's that?
We got 100.
Oh, okay. That's what I'm talking about. Good job, guys.
Cool,
Woo.
cool.
Yeah, that one, we had some thinkers in that one that put us on our toes, but we got it. All right.
Yeah, I think overall, though, it seemed easier than the other ones we've taken.
Yeah. No, I think this test is going to be easier than the last one. I hope so. But it's going to include stuff from both.
Yeah.
So
We'll
yeah,
see.
next week we have one more lesson. So lesson 14 is a new topic, and lesson 15 is a review of what we've learned the last whatever weeks. So, and again, I think it's going to be the same thing, so that on lesson 15, it's going to have like 30 questions. So what we should do is we should all answer those questions and then come to the meeting ready with those questions answered, and then we can take the test, be done, be quick. You guys agree?
Yeah.
All right.
Yeah.
Sounds good. All right.
But I think we should at least spend like more time explaining it after.
Yeah, answer what we can so we can see if we get the same answers. And then if you have any questions, you can't figure out an answer, put a question mark next to it, and hopefully one of us got it. If not, we'll figure it out together.
Cool. Sounds good.
All right. All right. Have a good week, guys.
You
Right.
too. Bye.